Okay, so this is 100% the last part. And I realized that the part of 18 I did, question 18 I did before, was a little bit disjointed and a little bit confusing. So we're going to start that one again. So for question 18, we have an unknown substance. It's either covalent or ionic, and it has some properties listed. Now, we did it, as I said before, we did a task that where we looked at a whole bunch of substances that were covalent and ionic, and we found that there were some general consistencies between covalent substances and ionic substances. Now, they're not completely true, like they're not true for every single covalent or every single ionic, but that's why we're going to build up some evidence to so that we can make a final statement about what this substance might be. So I'm going to start with ionic. So ionic substances, when it comes to appearance, often crystals, various colors. When it comes to the melting point, often a very high melting point. So when I'm talking very high, as I said before, I'm talking like 400 plus. 400 plus degrees Celsius. I don't need to say greater than when it's just 400 plus. But again, not always, but often. Now they have variable solubility in water, which means sometimes they do dissolve in water, other times they don't. So the fact that if something dissolves in water doesn't mean it is one or the other. But if soluble, they conduct electricity. So electricity is the movement of charged particles. Normally there are electrons moving through a wire. In this case, if we have an ionic substance, we have, let's say sodium plus and Cl minus. If it dissolves in water, it becomes that. And now we have charged particles that can flow around, just like similar to what electricity does. So if it's soluble, it should be conducting electricity. Now covalent, they often gas or liquid, but also sometimes crystals or solid. So again, like quite often they're gases or liquids, but not always. So for example, sugar is a covalent substance, and it is obviously a solid crystal. Cool. So next we have our melting points. So often very low to medium melting point. Okay, let's put point, whatever. So probably like negative 100 degrees plus. So it could be negative 100 degrees or more. Could be negative 50, could be 0, could be 100, but generally a bit lower. Now, solubility. Again, they have variable solubility. There is a reason for this solubility, but whenever they're soluble, there's a reason for it, but it's not really important. Some of them do dissolve, some of them don't. But the key thing here is they do not conduct. Do not conduct electricity when they do dissolve. So what we need to do is we need to build up a bit of a picture and work out which one of these properties of our substance tells us the most information. So first of all, with regards to the appearance, the fact that it is a solid leans towards our ionic. But when I say lean towards it, doesn't mean it is or isn't. It just leans towards it because more ionic substances are solid than covalent. Melting point is medium. So as I said, often ionic substances have really high melting points. Covalent often have really low. So this one's in medium. So I'd say medium, probably leaning towards covalent. as I said, it can be normally 400 plus, and this is under that, so maybe leaning towards covalent. I'm sure there are ionic substances with melting points this low though. So, solubility in water. So 200 grams dissolves in 100 mils of water. That is a lot, actually. Quite a lot. I should probably double check that that's for this substance it's true. But either way, that's very soluble in water. So high solubility could be either ionic or covalent. Not sure what's happening with the words there, but let's put it over to the side. I think it's messing up with the table. Ionic or covalent. So for example, if we have something like salt is like table salt is ionic. And it dissolves really, really well in water. Similarly, sugar also dissolves really, really well in water, and those are one of them is ionic, one of them is covalent. Now the last one is if it dissolves in water, which ours does, does it conduct electricity? And it says it does not. So this one here, heavily. This is annoying me. I'm going to have to write this outside. Heavily. It's still messing around. That's fun. Let's put it down here. Heavily leaning toward covalent because it is dissolved, but it doesn't conduct electricity. Whereas if it was ionic, if it dissolves, it would conduct electricity. So you would need to make an argument here to say that appearance doesn't really tell us much. Melting point is in between, so it tells us a little bit, but maybe not heaps. Solubility doesn't tell us much, but it does tell us it does dissolve in water. And the last one is probably our biggest one, which is when it is dissolving in water, does it conduct electricity or not? The fact that it doesn't means that it's probably covalent. Cool. And that would be your answer. I'm not expecting you to get it right whether it is or not. You will get marks for these arguments, each individual argument. But in this case, it seems like it's strongly likely to be covalent. And that's pretty much it. So hopefully this helps with each of these questions, and hopefully it helps you in future for other questions of these types. Because I don't want you just to be able to answer these questions. I want you to be able to answer any questions that are similar to this. Cool. Good luck.